Welcome, guys. So today we keep solving our physics subject GRE. So 54. So 54 asks you about EM wave, and ask you about if E2 equals E1. Then if you view along the z-axis from positive z and looking towards the origin. Okay, so this is the stupid difficult equation, that difficult question that your eye is from here, so you need to imagine there's I, and you're looking back toward. Okay, so your E is basically oscillate x at the xy plane, so you can let z equal to 0. So basically you have I only choose I already let z equal to 0. Okay, so you can use your trigonometric function identity. This is Euler identity actually, plus cosine. So there is a pi here. So when cosine plus pi, then it still it should be. So okay, so this is this one. This is pi. So pi cosine pi minus something, which is should be yeah, so should be negative sign here, and this is also another negative sign, so I plus I sine omega t y. Combine these two, and so basically we combine these two, we get basically x minus let me see, so this is the real part. Let me see, x plus y. Okay, and the E1 equal to E2, right? So yeah, this is correct. I.e. like sine. Okay. Oh, this is sine. Okay, so now we almost done. What we need is just the real part, right? Since we are working in the, we take a real part and we get this. Okay, so if you so what is this vector? This vector is basically cosine minus cosine, so this is negative, so this is a line. So if I see from here, this is what I see, right? This is what I see. So the angle is 135. So the answer is 135 to the positive, plot to the x-axis, right? This is positive x-axis, and then this angle is 135. Okay, and 55. 55 that if the plane wave is splitting and recombining on the screen after two portions, what is the amplitude, energy density? Basically, since you already separate, so density just their square, sum of their square. This is the answer. So 56, the light source is at the bottom of the water. So you have a light source, and there's a light, and this is 1.33. 1.33 is the reflection index, and this is 1. Somebody asked you about the total reflection angle. So 1.33 times sine theta is basically 1. So sine theta is basically 1 over 1.33. So which is close to like 0.85. Sorry, 1.33 is 0.7. So now the question is, what is which one is close to 1.7? So you see sine 60 is square root of 3, square root over 2, so it's 1.77 divided by 2, so it's 0.58. And the sine 30 is 0.5. So the angle must be between 30 and 60. So the answer is 50. Okay. So I usually have a feeling that the OGRE exam is more difficult than the previous and in the recent exam. I don't know. Maybe this just some illusion. Okay, so 57. Consider a single slit diffraction pattern for slit width is observed that for light wavelength 400 nanometers. The angle between the first minimum and the central minimum is what? Is this, and ask about D. Okay, so remember the single slit. We have the day sine theta equals m lambda. This is for the single slit diffractions. This is for a minimum. So now, which you have answer, you have what m equals 1. Basically, you know d, you know sine theta because you know radian and you know the wavelength, so you can calculate d. So E is, so lambda is 400 nanometers. Sine theta is this. So 100 10 to the 5, 10 to the negative 2. Let me see. Oh, this is 10 to the 9, right? Nanometers. So this is 10 to the negative 4. So the answer is C. Okay, so this is the helium laser. You have diameter about 1 meter. In order to convert the beam into a well collision beam of diameter 10 meters to convex lens. So you can view the two convex lens as a telescope. The first lens is focus 1.5 and is to be mounted the amount of laser. What is the focus of lens? Okay, so you need to know a formula of the telescope. Okay, so the telescope formula tell you that FO is basically FO divided by FI. Object divided by the I will be the magnificent factor. Okay, so basically what you have is that your diameter is 1, right? Go to 10, so it should be 10. And they tell you that the first lens, so first lens is what? So first lens is just the object. So object is one. So you are 1.5 centimeters. The first lens. Let me see. Okay. So yeah. So the first lens should be I. So the second lens is object. So this is 15 centimeters. Okay, so you choose 15. So you see you have D and E, and then your total distance is just your total distance. Usually is of object plus I. This is the usual telescope. But remember what we need to do is like the light is come from infinity. The light is come from infinity. And then we want also the distance of image formed by a second lens to occur a good far distance away. So basically, we have two distance which are infinity. So this is different from the original telescope. So the answer is just 60 from comes from infinity. So let's answer just D. So there's no need to add them together. Okay, and okay, so 59. You have approximate number of photons in femtoseconds. Plus of the 900 nanometers wavelength light from 10 kilowatts peak time is what? Okay, so 59 just basically equation. Basically, you know that E is HF, so it's H is light divided by the wavelength. So you know that this is somebody will tell you that you can compute this because you know the lambda, you know C, you know H, so you can compute. You got the one easy way is use 12400 divided by lambda, but you need to use Armstrong. So 600 nanometers is 6,000 Armstrong. So we can use this quick formula to compute to change into EV. So the unit is VeV. So what I got is like 2 EV. So this is the photon. Right? Let me see how to say. So the easiest way is that you have 10 kilowatts. So the total energy is this. Comes from 2 times 1.2 the N. So this is a number. Okay. 2 point, this is EV, right? So 10 times this equals to 2 times this. So we can solve N, just divide, use this divided by this. So what we get is 10 to the negative 5 divided by 3.2. And he asked about which A or B, which one is the answer? Which one is the answer? Oh, don't remember that this is kilowatts, so we need to time this 10 to the 3. So 10 to the 3. So basically 10 to the 8 is divided by 3.2. So it's close to 10 to the 7. 10 to the 7. So 60 the Lyman alpha in hydrogen differs these meters in the spectrum opposite ends of sun's equator. What is the speed? Okay. So this is actually about what? The Doppler effect. And the important things, usually what we need use the Doppler effect, we just use the so this is for the light, right? So lights use the light Doppler effect. This beta is V over C. So this you can compute the delta lambda. I define as this. So this is lambda plus 1 plus 2 beta. So square root, yeah. So beta. So this is close to lambda times beta V over C. Okay. But remember, this question is just asking about taking opposite ends of the equators. So basically, one is V plus C, one is V minus C. So your delta lambda actually is 2 lambda V divided by C. 2 lambda V divided by C. Okay, so I think you can compute it. So this is the differ. 1.8 times 10 to the negative 12 equals to 2 times the original lambda. 9 times V, we don't know. 3 times 10 to the 8. Okay, we compute V. Okay, and the V I get is B. I get 0.2. Oh, so that means our approximation is still okay. our approximation is still okay. Let me see whether it's, yeah, so it's very close to 2.22. Okay, so I think it's enough today, and I will see you guys in the next video.